Hello all. We are learning the Simulink library browser where in a Simulink library browser we are learning the ports and subsystems. So in a ports and subsystem just now we have finished the conditionally executed block like trigger, enable and function called blocks. So on this the block we are using the subsystem like enable subsystem, trigger enable subsystem, function call generator subsystem. So now we will learn about that subsystems. Okay. So here you can see and have the four types of subsystem. These subsystems are known as conditionally executed subsystems. Okay. So the very first subsystem is enable subsystem. So here you can see the enable subsystem I have created. One example where here you are able to see one pulse wave in that way something. This is the logo of enabling the subsystem, enable subsystem. Inside it, I'll be having the enable block. This enable block is having a setting of held and reset and duration or during execution or while enabling. Okay, when enabling the signal at the time only we have to that variable size want to resize. Okay, fine. So now here nothing inside here, no logic will be here. Only output is directly connected to the input is connected to directly output where I'll be passing a sine wave as an input. So in that sine wave, I have given some frequency which is 2 pi into 1. That is 2 pi r, the frequency and amplitude is 1, bias is 0, phase is 0 and sample time is 0. Okay, and that enabling signal here I use a pulse generator where my pulse generator is having time based and that your simulation time and amplitude is 1, period is 1 and duty cycle like pulse width, that duty cycle I have we take it here as an 50 here. Okay, and phase delay is 0. Fine. So here what happened if I am directly passing a sine wave here inside it, what enable signal that enable subsystem will do. So in a basic way, once that pulse is high, okay, when it is moving from 0 to 1, at that time was the sine wave will be enabled. Or once it will be going from like 0 to minus 1, again coming to the 0, at that time that sine wave will not be visible at the output of this enable subsystem. Okay, now I'll simulate this model in front of you. Okay, now we can see the output in this scope. So here you can see in this scope where I'll be having out. This is okay. Here I'll come in a view and I'll make it to the region. So I'll get some names here. Which sine wave is which signal is denoting to us which wave. Okay, here you can see this is a pulse generator, this is a sine wave, and this is a enable subsystem output. So when you can see that my pulse is going 0 to 1, 0 to 1, 0 to 1, 0 to 1, 0 to 1 in that one. And sine wave is having amplitude of 1, so it will go plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, it will go. Okay, but that enable subsystem enabling the system only at a positive pulse of a sine. It will not go to the negative part. It will stop there. Again, it will go to the positive pulse of that sign. So according to the positive pulses, it will give us the output that enables subsystem. Okay, so there are various settings and we will get a various output for that. So enable subsystem executes when the control input, that input at the top is true. Once that input like once it is a true, you can see here in this graph, once it is a true, okay, and that time only this is working. Once it is a false, at that time it is not working. In that way it will work. Okay, so we will learn about the next subsystem now, that is a trigger subsystem. So trigger subsystem executes when the control input has a configured trigger. Okay, so their trigger subsystem can have following triggers, like we have three triggers: rising, falling, and either like where rising or falling both should be worked here. So for the trigger subsystem, if I am coming here and like make it a little bit zoom this, okay. Okay, fine. You can see here in this trigger subsystem, you are able to see one uh, pulse, and on that pulse we have upper arrow. So this thing is known as a logo of trigger or trigger subsystem. So here also I'll be using input as an sine wave with a same configuration where 2 pi r, and like r I'll be using. Yeah, okay, 2 pi r or 2 pi. Whatever I want, I can do, no problem. But in a pulse generator, I'll be changing the time rate to 0.1 to increase the number of pulses in a like in previously it was 1, so to 0 to 1 it will be having one positive, one negative, like for half it will be positive, for half it will be negative. Now my for 0.1 it will be like for half it will increase the type samples. You can see in a graph, okay, here previously it was like from here to here only one was there, that positive and negative, but now here we have in between that 10, because I have set up rate as a 0. But now if I'm coming inside it, the trigger subsystem, I haven't connected any logic here. Only I will be showing what changes are going to happen at the output. Okay, fine. So here the place of this block, we can use a subsystem root level of a model to create a trigger or function call system. Okay. If the trigger subsystem rising, falling either and placing that block in a root level of a model enables a signal attribute tag. So we will see one by one, raising, at falling, or at either what will happen. First, I'll make it at raising, where my sine wave and pulse will be going. So if I'm simulating this model, okay, so what will happen? It will work only at rising edge. Okay, it will work only at rising edges. Okay, here that falling edges also it will going to the down according to sine wave. But if I am coming this rising edge, so it will be raised, this rise. Okay, here I'm not able. Oh, okay, in that way it will work. I'll show you now what will happen at a falling edge. If I am going to change this rising to the falling, change in a graph, you will able to see now. If I'm simulating, now you can see these are like when it is a falling edge. First you can see this is my rising edge, this is my falling edge. On that falling edge this is high, and that second falling edge, this one was my second falling edge. On that second falling edge it will be going to the high again till the third falling edge. It will be here only, like this falling edge. After this falling edge it is going to the again high, again that until next falling edge it is going to down. According to sine wave it is working, but rising and falling edges are detected here. Previous one was it's going up on the rising edge, now it is going up on or down on a it is following the pattern of the sine wave on a falling edges only. Okay, so now I'll show you here. Previously it was, if you are able to see, this logo was going up arrow when it was a rising edge. If it is going down arrow, that means it is a falling edge. Okay, on this subsystem, if I am making this to the either, then you are able to see the both the arrows here, up arrow and down arrow, both the things will come here. So yeah, that means it is work on rising and falling edge both together. If I'm simulating now, you can see you will get much more better result here. Corner scope, you will get this, it will increase on, it will follow the pattern at rising edge as well and falling edge as well. So here we have increased the number of steps. You can see previously it was using 2 step to go middle and 2 step to go down in that way, but here you can see 5 step now is increased because that performing of pattern of sine wave at both the edges, rising and falling edges. Okay, so that's all about the trigger subsystem. So trigger subsystem. Now we will learn about the enable and trigger subsystem. Now, what does the enable and trigger subsystem do? So enable and trigger subsystem execute when a control input for enable is true and configured trigger is received on a trigger control. So if just now we have finished the enable and trigger subsystem. So what happened in that scenario? The enable and trigger both will work together to run that subsystem. Okay, to run that subsystem, enable and traverse subsystem. So here also I'll be having a pulse width which is connected to the rising and falling edge with 0.1 period and 50 duty cycle. And here that enable subsystem which is having time 1, and it is enabling that the subsystem at this using the enable. Okay, and this is my sine wave which having a same configuration 2 pi r. Okay, now if I'm coming inside this block enable and trigger subsystem, we are having the both the blocks, trigger and enable. And trigger I have set on either. If I am setting on rising edge, okay, and enable, what it will be, okay, reset, no problem, reset or held, whatever it will be. If now I am simulating this model, you can see the graph. Once it will be enabled and it will be a rising edge, at that time only my graph will plot. Okay, so you can see here my duty cycle here like my 50, and I will be getting 0 to 1 only. So here you can see once it is a rising edge here, once this is the first rising edge where I will be getting this rising edge. Okay, on that second it is these rising edge I'll be getting here, then it will be down, and again it will be getting down and getting up. So it work on only rising edges, and with the match of this both of the two. Okay, this and it will follow this sine wave. Okay, so if I am making this to the falling edge, this one. Okay, and now you can see what output we will get. Okay, first I'll open the scope. Here itself I will run. So you are able to see the change in a graph. Okay, you can see now it is working on falling edges. Here it's increased some falling edges. Okay, now I'll make it this trigger to the either. It work on a both like rising and falling edges. So what kind of output I'll get it now here? So you can see the scope and open the scope. You can see rising and falling both the edges are detecting, and it is working till only positive cycle, because we have enabling condition also here. It's enabled till positive cycle. Previous all are in a same only. It's working till positive cycle only because we have that enable subsystem. Enable is only work on when it is enabled period. Okay, on you can see directly till here it will work, but it will not work at a negative cycle. But in a trigger subsystem, if we use only trigger subsystem in a previous graphs, okay, if you want to see here, it's work on rising and falling both the edges. But here I will be using enable and trigger subsystem. So that's why it's work on only the positive part of the sine wave. Okay, that means only the that enable part of this signal. Okay, so that's all about the enable and trigger subsystem. Now we will learn about the function call. So function call subsystem, the function call subsystem executes when a valid function call is received. These function call can be generated either using function call generator or from a state flow. So we will see here in this subsystem, if this function is written function and in this circular bracket is there, that means that function is required to run this subsystem. That function may be the output of that state flow. Okay, output of the state flow somewhat can connect, or we can use directly this function call generator block. We have already studied the function call generator block here as well. Okay, what's the function call generator block? Execute a function call subsystem at a rate of specific by the block sample time parameters. It's execute a multiple function call subsystem with pre-subscribed order, first connecting a function call generator block. Like we can use so many operations here as well, this by using this. Okay, now here in this system, there the function call generator is created. Here in this function call generated, I have given a sample time as an 10. Okay, as an 10. Here it will work on particular sample time. I have to give some sample time which is matching with my this as well. Okay. So if I want to use something different, if I want to use 50, okay. So does it work? Yes, it is. Why we use this function called generator block? If we want to run this system a part of this our given like solver setting times, okay, a part of this solver setting times, okay. Here I'm getting 16. Why? Because here I have a simple addition logic which is getting going to input add with a 15, okay, and my input constant was here 1. I'll change it to somewhat if you want 5, so I'll get output as a 20, okay. uh, uh, here's like how it will be working. It will work only with this only. If I'm trying to write something else, it will not work. But what is a main purpose and an industry how we can use this function called block and why we can use this function called block? Okay, so first thing is I have one collision image and braking system model in IR's feature where my complete subsystem, like my complete model, is working on some 20 millisecond time. Okay, some 20 millisecond time. But there is one specific feature like airbags that will be run much more faster. So I want there like 100 milliseconds. It will run in 100 milliseconds instead of 20 milliseconds. So if I am implementing the airbags logic inside the collision emission braking, where that CIB is calling that airbags logic, but that logic inside it, but it logic that airbags opening, it will work on 100 milliseconds, like that is less than the 20 millisecond times, okay. 100 milliseconds are less than the 20 milliseconds time, like which we want quicker operation. Like my whole model is having sample time of 20 milliseconds, but one of my logic is want to work on some another sample time, like another time, okay, another time step. So for this purpose we can use the function call generator where we can set this for sample time. If I want to like 0.01, that means it's a 10 millisecond. Okay, if I'm running, so it will work on that as well using this. So this is a main purpose to use this function called generator block. So that's all about these conditionally executed blocks. We have studied these 4 types of blocks. Enable subsystem, where the enable subsystem executes when the control input at a top where it is true. We saw here it is showing a enable logo. Another one is trigger subsystem. Trigger subsystem, here we can see the logo of trigger. It will be rising edge, falling edge, or either, means both rising and falling both. Function call generator, where it will work on some different sample time apart of this execution time what we have given, okay. And enable and trigger subsystem, where the enable and trigger both the logics are work together and to run the subsystem, okay. So that's it all about the conditionally executed subsystem. In next session we will learn some another topic. Thank you.